All right, hello everyone, and a warm welcome to all you students from the Ksoft Labs Institute. Today, we are diving deep into what I like to call the brains of any Java program, control flow. Think of these as the essential tools in your programmer's toolkit. They're what allow your code to make smart decisions, to repeat tasks tirelessly, and to handle curveballs without breaking a sweat. In short, they're what turn a simple script into a dynamic, intelligent application.
So let's kick things off with a really big question. Have you ever been playing a video game and just marveled at the sheer complexity on screen? Or scrolled through a social media feed that's constantly updating in real time? It feels like a million things are happening at once. Now, you might think that means there are millions of lines of code, one for every single action, but that's not it at all. The real secret isn't brute force, it's elegance. It's all about control.
And that idea of control brings us perfectly to our first set of tools in the toolkit. These are all about mastering the art of repetition. The answer to how programs do so much with so little? It's loops. These are incredible structures that are designed to run the same chunk of code again and again and again with amazing efficiency. No copy-pasting required.
Okay, so what exactly is a loop at its core? Well, it's pretty simple, really. A loop is basically a gatekeeper. It asks one simple question over and over. Is this condition true? If the answer is yes, it lets the code inside run. The moment the answer becomes false, the gate closes and the program moves on. It's like an automated worker that never gets tired. In this little example here, our program is going to keep calling that add water method as long as that soil is dry condition is true. Once the soil is moist, the loop stops. Simple as that.
Now, this is where it gets interesting because not all loops are created equal. You have to pick the right tool for the job. On the left, we've got the while loop. I like to think of this as the cautious bouncer at a club. It checks the condition, your ID, before it lets you in. If the condition is false right from the start, that code inside, it never even runs, not once. But then on the right, you have the do while loop. This one's more like a try a free sample kiosk at the mall. It lets you run the code once, guaranteed, and then it checks the condition to see if it should run again. This is absolutely perfect for things like a main menu in a program, where you always want to show the options at least one time before asking the user if they want to quit.
So while and do while are fantastic when you're waiting for some condition to change, but you don't know exactly when that will be. But what if you do know? What if you need to do something exactly 10 times, or for every single item in a list? For that, we have the workhorse of loops, the for loop. This is your precision tool. What makes it so great is that it bundles the entire looping logic into one clean line. You've got the starting point, your initialization. You've got the stopping condition, and you have the increment, what happens after each pass. It's like giving your loop a GPS with a start, a destination, and a route all at once. Here, we start I at 1, we keep going as long as I is 10 or less, and we add 1 to I each time. Perfect. Okay, so we've got our loops up and running. We know how to start them, but what about steering them while they're in motion? What if we need to be more of a conductor for our code's orchestra, not just the person who presses play? Well, that's where our next set of tools comes in, giving you that pinpoint advanced control over your program's flow. Now, this concept, this is a real game changer. Nested loops. It's basically the inception of programming, a loop within a loop. Think about it like the hands of a clock. For every single time the hour hand moves, the minute hand has to do a full rotation. It's the same idea here. The outer loop runs once, and for that one single run, the inner loop runs to completion. This is incredibly powerful for working with anything two-dimensional, like a grid, a spreadsheet, or the pixels on an image. In our example, x will be 0, and then y will go 0, 1, 2. Then x becomes 1, and y goes 0, 1, 2 all over again. All right, so imagine you're searching a massive list, maybe a million user accounts, and you're looking for the first administrator. You find them on, say, item number 50. Are you really going to waste time checking the other 999,950 accounts? Of course not. That's where the break statement comes in. It is your emergency stop, your eject button. The moment your code hits break, it immediately terminates the loop it's in, and the program continues on from the next line. It's super efficient. Just a word of caution, though. Use it wisely. If you start sprinkling break statements all over your code, it can get really confusing to follow the logic. Now let's contrast that with break's cousin, the continue statement. If break is the stop button, continue is the skip track button. It doesn't end the whole loop, it just says, you know what, I'm done with this current round. Let's just jump straight to the next one. It's perfect for situations like the one on screen, We're processing a list of numbers, but we only care about the positive ones. The moment we see a negative number, continue tells the loop, all right, skip the rest of the code for this number and move on to the next item in the list. So far, we've pretty much lived in a perfect world, where everything goes according to plan. We've been programming for the happy path. But here's a secret. What separates good code from great code is how it behaves when things go wrong. Professional, robust programs are built to handle the unexpected. And to do that, we need a technique called exception handling. Let's paint a picture of a super common scenario. Your program politely asks the user for their age. You're expecting a nice, simple number, like 30. But your user types out the word 30. Uh-oh. Your code, which is set up to handle an integer, now has to deal with a string of text. What do you think is going to happen? It's not going to be pretty. Without a plan, your program is going to crash. Hard. Bam. An ugly error message flashes on the screen, the application closes, and your user is left wondering what they did wrong. That's a terrible experience. A single, simple mistake shouldn't bring the whole house down. And the good news is, it doesn't have to. We, as developers, can anticipate these problems and build a safety net right into our code. And that safety net is this beautiful structure, the try, catch, finally block. Here's how it works. First, you put your risky code, the part that might blow up, inside the try block. Then, you set up a catch block right underneath it. This block acts like a spotter, waiting for a specific type of error. If that error happens, instead of crashing, the code inside the catch block runs, letting you handle the problem gracefully. And then there's finally. This block is special. The code in here runs no matter what, whether there was an error or not. It's essential for cleanup tasks, like closing files or network connections, ensuring your program always leaves things in a tidy state. Okay, let's just take a quick step back. We've covered a ton of ground here. Different kinds of loops, statements to control them, and safety nets for when things go wrong. These might feel like individual little tricks, but they're not. They are all pieces of a much bigger puzzle. Let's connect the dots and talk about why mastering this toolkit is absolutely fundamental for you as a developer. So what's the big payoff? Well, first, efficiency. With a simple for loop, you can automate 1 million tedious tasks with just 3 lines of code. It's an incredible force multiplier. Second, readability. When you choose the right tool for the job, your code becomes self-documenting. It clearly communicates its intent, not just to the computer, but to other developers and even to your future self. And finally, and maybe most importantly, maintainability. Writing code that anticipates and handles errors is what creates robust, professional-grade software that people can rely on, and that's easier for you to update down the line. So as you move forward in Unit 2, as you start tackling your programming assignments, I want you to think of yourself not just as a coder, but as an engineer. We've just handed you a powerful toolkit. Every loop you write, every try-catch block you implement, it's a deliberate choice. You now have the ability to build solutions that are not only functional, but also efficient, elegant, and resilient. You have the tools. The only question left is, what will you build?